Okay, that means it's working. This is the week where I get all the emails. I know I didn't do anything all semester. Can I make it up? Can you hear me, Daniel? Meow. So. Can you hear me? Can you hear me?
Yeah, I can hear you.
Good. Excellent. Thank you. Okay, that means it's working. That's good. We'll wait a few more minutes, let a couple more people show up. It is being recorded, so just be aware that if you start singing your favorite song or something, the microphone might pick it up. I brought my laptop originally. I was going to do that, but then I was like, you know what? This is a bigger screen and has excellent writing capabilities on it, so I like it. So the test, final exam becomes available today at 4 p.m. Now, obviously, that does not mean that you have to start it today at 4 p.m. You can start it pretty much as long as you finish it in between this time, December 5th and December the 14th. You are welcome to start it anywhere in that time. So don't start it at December 14th at 11:50. That's probably not enough time. But I would say for the typical student, I would say it probably takes anywhere from, I mean, some students might be able to get it done in maybe an hour, but I don't think that, don't be like challenge accepted. I think it's probably closer on average to 2 hours, but some people might need 3 or 4. That's fine. So just do your best. Notice it is 200 points. It is also any category which has some pretty high percentage, right? So it's the only thing in its own category. It's 30%. But that helps me, the 200 helps me spread the points over more questions and kind of decide incrementally what to offer. So that's 30% of the grade. Besides the other 2 tests, that's a very large chunk. Now, as far as any individual single item, that is the item is the final exam. So don't start it if you're not ready for it. That's another good recommendation. How was everyone's week? Doing well? Everyone's excited? That's good. I guess I think the majority of it looks like the majority of the people in the class decided they would take the asynchronous route and listen to the recording. It'd be really funny if I flubbed and accidentally deleted the recording or something. That would be kind of cool. So I'd get a lot of sad emails. It would be very sad. So, or maybe everyone's just that confident. That's possible too. For those joining online, we'll probably get a few more as the time goes on, but for those online, just make sure to click the hands up. The hand up indicator if you wish to answer or ask a question. It actually does do a little pop-up. So it should pop up and say someone's, asking a question or raising their hand. So, but when you are done, please put it down. All right. What are we doing here? Okay. So this one, I didn't print out like a specific set of questions to go over. It's just, I figured we'd kind of slide through quickly some of the highlights of some of the slides based on the study guide to make sure where to find them and everything. So for the study guide for the final, there are 12 questions. Several of them are multi-part though. They're all practically all, I guess you would say, calculations, short answer type stuff. Number 1 is 15 points. Given a regular expression, explain in English what accepted strings look like. So the regular expression stuff was in, you probably don't really need to worry about chapter 1 or lecture 1 that had mostly kind of historical context in it. So I don't know that I would worry about that one so much, but starting with slide deck 2, if I can move that out of the way. Yeah, so lecture 2 slide deck, you should be able to start there. That's probably the best place to start. So if obviously you need the fundamentals, you need to know what this different syntax means, the shortcuts, the strings, the cardinality, what is a reverse, what is a language, and obviously in the context of sets, the Kleene closure is very important, or Kleene star. So you should know what that means. It means you repeat 0 or more times the thing that precedes it. So it's a unary operator, right? And remember not to overuse unary operators because you get a urinary tract infection. See, we did that joke before. I know that was probably why I got the Reddit joke complaint. That was kind of a Reddit joke. So if also the other thing for students listening at home or on the joining us from here, anyone else trying to bust in? Okay. Try to fill out, speaking of bad reviews, try to fill out the official review through the college, which is the course. I think they just call it course evaluation or something. So it's got 2 different sections. It's got a section where if you don't like the course, you can complain about the course in general, or complain about the instructor, complain about both, talk about how much you love both of us. I'm personifying it, which is weird, but whatever you like or things you'd like to see, that's fine. So, okay, so we got Kleene star. Kleene plus, you do not use in regular expressions. We did discuss that. Methods for modeling languages, we did talk about that, how kind of recursion plays a role in this, and a specific type of recursive model is using irregular expressions in languages. So we said that doing the actual regular expression or using the regular expressions, the recursive step, base case is basically lambda and any element of the alphabet sigma is a regular expression, or could be a regular expression, could be included in a regular expression. This is basically saying what could be included in a regular expression. Once you establish the regular expression, that then defines what's in the language or the words that are that the regular expression generates. So we talked about parentheses being valid, concatenating different symbols, so you can concatenate regular expressions. You can also use the or operator, which is plus. So you've got conjunction, that's the concatenating. You've got disjunction, that's the plus symbol, which is the or operator in this context. And you've got the unary operator, Kleene star. Okay, that's pretty much that. Given a regular expression, explain in English. Okay, so it could be something like, I think right here. What does the regular expression? Yeah, so examples like on slide 29 in the second slide deck would be very good to review for the final exam question 1. So this is things like, what does this regular expression mean, right? What does this one mean? How is that one different, right? So give the regular expression for all strings of at least length 1. So that's kind of the reverse. I think, is it number 2? Oh, that's number 3. So basically, this is kind of the reverse. Write a regular expression based on the description in English. So I think they're, yeah. So that's like these two. So basically 30 points of your final, if you can kind of look at the slides hovering around the 27 through 29 mark, you'll be way ahead of the game. Okay, so do that. Transition, state transition diagram for a finite automaton. I don't believe, were there finite? Yeah, they were. Okay, so we have finite automata even starting in lecture 2. So these were the examples of finite automata starting on slide around 42-ish. In the lecture 2, you can start looking at these and saying, what does it mean? So here's an English description, starts with substring ABA, and you can see, so ABA. With the finite automata, if you'll remember, just to knock some cobwebs off, the finite automata have to represent a total function, meaning if you look at any states that you decide to have in your finite automaton, they have to have outgoing edges of some sort, considering all the symbols in the alphabet. Okay, so our alphabet is typically AB, so that means there should be 2 outgoing edges or an edge representing outgoing, 2 outgoing edges. So this one, for example, this still counts as 2 edges, even though it's a single loop, because it has the B or the A. Same thing over here. Okay, any questions about that from either the in-person or our friends online? One second, I keep forgetting I have to do this. Any hand raisings? No. I thought everyone would jump on the Zoom opportunity. We only got a few today. No. Okay, so that covers the kind of the first part of this, first 4 questions approximately. One moment. So there's what's 70 points of your 200, just if you can do those kind of correctly. Give a Turing machine configuration after correctly applying a transition function. So that was also the first half. Was it lecture 5, 6? I don't remember. 5. Okay, so lecture 5 contains the stuff for the Turing machine. So nothing on nothing explicitly on push down automata or context free languages. Okay, so you should have a basic idea what these things are in case there's some context given, but knowing what a regular language is, context free language, and then context sensitive language. Context sensitive languages can be recognized by Turing machines, right? So this one, the primary thing was, what is the Turing machine? What does it do? It's a model of a modern computer. Knowing that diagram might be helpful. But primarily, if you're looking for specific slides to study in the lecture slide deck 5, starting with slide 15, you will have more of the material in there. Okay, so this is a configuration. Given a configuration, or you should know what the configuration represents and how to draw it this way. I did on the previous one of the previous tests, test 1, I guess. Test 1 have some students were like trying to do their own custom syntax or something. Is don't get creative with this. Okay, don't get creative. Creativity is great, but not art history majors. Okay, so you need to kind of pay attention to this. You have to know that the state of the machine itself, the internal state, is represented by the, say, Q sub 5, that represents an internal state. So this says I'm in state 5, okay, internally. And then the input string on the tape, at least some of the characters of it, there's not really a specific number you need, but I would say probably, shoot for like 8, 9, 10, something like that. And you can see right here that Q5, the read head, is reading the 0, which is the first character of the remainder of the string to the right of the read head. So it always reads, no matter what direction it just got done moving, whether you moved left or right or stayed, it's always reading the first character to the first symbol to the right. Okay, does that make sense? So even if I moved left, it's still reading the first character to the right. That's something some students got wrong on the test, the first test. Okay, you should know what a transition function looks like. So it's these delta things. And also the other big thing, despite my best efforts in making sure that everyone knew what they were supposed to do, I can only conclude that a lot of the online students just do not watch the lectures. That's the only thing I can conclude, or they have me on, like, speed run while playing Lethal Company in the back, or I don't know. It's something silly. I have no idea. But the reason I conclude that is because people still applied this function multiple times, or kept going until they couldn't go any farther. That's not what I might be asking. If I say apply it once, that means pick one transition function that works properly with the given input. For example, if I'm in Q sub 5 and this says Q5B, I would pick this one. I wouldn't pick Q5A or Q4B. I would pick Q5B because that's the one that it points to. And then this over here on the right side, the return value, if you will, of this transition function tells me where to go from there. Now that J could equal I, meaning internal state could stay the same. It's telling me to write a C and then move to the left. So don't move on the tape until you've done the writing, okay? Any questions on the configurations? Anything? Bueller? Okay. 1980s movie? No. Ferris Bueller's Day Off? Anyone? No one has seen it? You've seen it. See? We have some people with class in this class. What's that? How you do what? No, what are you saying? That's QI. That's Q sub I. That's a variable right now. But in reality, you'll see it as actual examples, like with particular numbers. So like here. Okay, so if I see it's Q50, then I would be reading the 0. And let's say the transition function said move to the left. I would then read the 0, write a 0, move to the left. I would move it over here, right? To the left. That makes sense? Right. Yeah, so you're going to be given the initial configuration. You have to figure out what to do from there. What is this? Was this 2 or 5? That's 5. Okay. This is 2. We can close that. Okay, so that's a Turing machine. Determine whether strings are accepted by a transition graph. I skipped that one accidentally, I think, but just as a reminder, that would also be kind of in, I guess, lecture slides 2 There might be honorable mention in 3, but it's kind of near the end of lecture slides 2. Remember that what's the difference between a transition graph and a finite automaton? A transition graph relaxes some of the rules, right? So you can have lambda on an edge, for example. You can have full strings on an edge. Is that right? So I know all of you loved that structure. So that's why everyone loves it. So you might be asked, I think that one's just determining whether the string's accepted. I don't think that one has to do with converting them. So I think you just have to worry about that. I tortured you enough with that on the quizzes and the first test. So I figured you could mostly focus on the second half. So now that's the first 5 questions of the 12. So it's smaller number of questions than the remainder. The remainder of the final, it's actually majority second half of the semester. Okay, so starting with question 6 worth 20 points. Let's make sure no one's asking questions. No questions yet. Okay, so number 6 worth 20 points. Solve modular arithmetic questions using the integer representation x equals cq plus r or qc plus r, whichever you prefer. And then also remembering that r is always negative. That was in the second half. So that would be, I think, lecture 7. So I would say for this particular question, you want to pay a close attention to the modular arithmetic stuff, which is in, starts with slide 18, number theory. Number theory, again, is the theory of how integers and primes relate to one another and the world, the lovely world around us. Right. So the modular arithmetic, see one here? So yeah, string representation, obviously congruent stuff. I'm not sure if that's on, did I say that? Yeah, determine congruence between 2 integers. So that's number 7. So number 6 and 7 are both related to slide deck 7. So the first one is basically solving or putting them in the format right here, slide 22, starting with slide 22, of the x equals cq plus r format, and solving these types of problems, like what is 57 mod 12? Don't just use a calculator or write it out. So pay attention to what you're doing. And then there's the congruence modulo. So like these questions, right? Is 9 congruent to 4 modulus 3? Euclid's algorithm. So Euclid's algorithm is also in this slide deck. So you got about 3 from this slide deck. Euclid's algorithm starts on slide 38. Okay, this is for finding the greatest common divisor. It actually does have a more efficient big O than the brute force technique. Brute force technique is n squared, I think, and then Euclid's algorithm, I believe, is n log n, off the top of my head. So Euclid's algorithm had to do with the GCD of m comma n for positive integers m and n. They have to be in this particular order. So m has to be greater than 0. Well, I guess greater than or equal to 0, but and then n greater than or equal to m in order to find what their greatest common divisor is. You can then do a little swap-a-rooney and say n mod m comma m. Okay, so the m, the original m, moves to this side and becomes the next round's n, and then the n mod m becomes the m for the next round. Okay, so the first parameter of GCD. So we did talk about that pretty extensively. Most people did pretty well on this. I think the majority of people that I have graded test 2 for thus far have gotten this correct. There's been a couple that did not. Well, missed one or something for usually silly little miscalculations or didn't pay much attention to what they were writing down, or copied a problem they found on Chegg from a previous test. That's fun. So that's cool. That's my favorite because that shows me like people aren't even reading the problems, which makes it even funnier. But you know, whatever. Okay. So I'm not like the nice professors that would just, fail you on everything. and then or make you retake the class or expel you. I'm the mean professor that lets you get away with it, and then you get into industry and your life gets ruined because you don't know shit. So that's I'm the mean professor. So don't cheat. Euclid's algorithms for GCDs. Next one, given points, find vectors. Okay, these are go out of number theory and start going into. Wait, did I? Oh, there's a big one. That's a big thing for the final. I think since I tested it already on test 2, there's no game theory, so you can skip an entire slide deck. Woohoo! Right. So focus on 7 and 9. So 9 is the computational geometry stuff. Computational geometry, applied linear algebra. This was a fun one because grading it, I know there were probably, I'd say 3 students so far that did not use the formulas that we discussed in class. They used I think they Googled it or asked ChatGPT to do it for them and then pasted their answer. It came up with the right solution or right answer, but it was not the right solution. So I took about 8 to 10 points off of the 10-point problem. So use the techniques we learned in class. I'm not interested if you give me the answer or can use a calculator or phone a friend or chat GPT. I want to see you work out the problem in the techniques that we used in class. Okay. And some people I think just forgot. They just kind of like said, they thought, oh, this is the way you do it, and never watched the lecture or weren't paying attention, and then just kind of went with the. Yeah, I mean, I can't do anything about it, so I'm not going to. I recommend making a cheat sheet, but yeah, students you can look at the slides as far as I'm concerned, because I'm not going to be able to do anything about it. But asking Chat GPT, phoning a friend, polling the audience, don't want to do that. No. Okay. So, but if you're doing the work, that's great. I still recommend a cheat sheet, even if you have access to the slides or your notes or whatever, because it makes it so much quicker. You can take the test a lot quicker. If you have and I go question by question, so you literally know what topics, so you can make notes about those topics in order, and then you won't have that big of a problem. So I would say try to get it on one sheet, both sides, if you can, because that will force you to put important information down. But I'm not, double checking or sneaking up to your house at night, making sure you're not cheating or something, or looking at a slide. I'm not allowed to do that anymore. The administration said so. Okay, so given points, find vectors. This was kind of our first major discussion in this. So the vectors, we realize that the vectors are geometric quantities with direction and magnitude. And given points, so if I give you 2 points and say, hey, there's a line segment, here's some points, find the vector. The way to find the vector is you have to pay attention to the wording, because it'll say like from this to that, or to this from that. So just pay attention to how the wording is. And from context, you can determine what is the initial point and what is the terminal point. Okay, and then you take the terminal minus the initial. Okay, so for the x value of the vector, it's 5, which is the terminal, minus 1, which is the initial, and then 1 minus 3. So that gives me 4, comma negative 2. Right? That one was actually in the book, but the answer was wrong in the book. So magnitude. Yeah, given vectors, find magnitudes. Now you can assume these are very likely multi-part problems. Off the top of my head, I'm not trying to be like elusive. I just think there's 3 or 4. I can't remember, but it's like 3 or 4 subparts for each of them. This one could give you an entire new set of vectors, or it could say refer to the previous problem and find the magnitudes. So the stakes are higher if I did that, right? Because you got to make sure that this one is correct. There we go. You got to make sure that this one's correct for the magnitudes to be correct, or it's going to cascade and cause you to lose points. I do give partial credit. I try to be a little bit generous in how I, give partial credit and stuff. Because I mean, like if you're screwing up frequently on tests, I don't want to see you again. Anyway, no, I'm just playing. That was a joke. So if you do the problems wrong and you get them wrong, if they're close, you will probably get some partial credit. Like if I was like, oh, it makes me sad they didn't divide that right. It's like I've had usually it's the funniest errors too, because it's usually students are like, it'll be like 9 divided by 3 or something, and they'll be like, it's 2, they get really excited, confident. So don't do that. Or the 3 squared equals 6. That's my favorite one personally. That's a good one. So I'll be like, oh, that's sad. Here's the points. Oh, and an extra pity point. Also, test 2, people were turning it in with things circled in hearts. So it was definitely on purpose, yes. I gave extra credit and then took it away for using I was like, I really like these hearts, plus 2 points. And then I said, but that's terrible, minus 2 points. So it broke even. So some of them were very aggressive with the hearts too. They were like really detailed. It was like super like colored in and pretty. And okay. So that's Euclid's algorithm. Given points, find vectors. Vectors find magnitudes. And the last 2. Oh, something seems wrong. Something seems wrong. Watch just a minute. Oh, it's still sharing the screen. Damn, I'm gonna look on my phone. I don't trust you guys. I'll probably make it go off here, but then my Zoom people will still be able to see it. Give me 1 second. Something's not right. Or I feel like something's off. Oh, they are? Oh, shiz. Oh, well, that's probably been sitting there for like a half hour. Okay. Sorry about that. Okay, academic Canvas. I was so excited about computational geometry, I failed to notice there was a person there. Okay, I'm almost in. I'm looking at it on my phone, so for those of you confused. Okay, what are we doing? Am I logging in? Yes, I am logging in. Thank you. Looking at the exact final exam you're taking. I thought for sure there was a surveyor's formula question, but let me double check. It just doesn't feel right. I know there was one on test 2. Don't worry, almost there. Oh, that's cool. Don't want to install that. You want to install Canvas? You want to install that for your phone? I already have it. Okay, there we go. All right. Uh-oh. Okay, nope, I guess there isn't. All right, well, that's sad. I thought there would be at least an exciting surveyor's formula one on it. There's not. There's no surveyor's formula. There is a distance from a point to a line. So that would be also in this set of lectures or set of slides. So that would be in the line to point distance. That's the first part, starting around slide 19. So that's the line to point distance. You'll need to know that. So no intersection question. And knowing how to find Jacquard similarity. Okay, Jacquard similarity and working with shingles. So this one said, know how to find shingles of documents and the Jacquard similarity and distance. So given a document like this, if I'm given this document right here, this is slide 15 on the special topics similarity stuff. So it's in this part. Jacquard similarity was earlier. Okay, that's kind of the earlier part of the slides, I think. And that basically is the magnitude of intersection over magnitude of union, right? That's our Jacquard similarity. Jacquard difference is 1 minus that, right? So a document, if I have a document, it's going to be relatively short. Okay, it's not going to be a full document, obviously. I should give you the Gettysburg Address and make you do sets out of it. Okay, so we would look here, and if I have a K equals 2 or a 2 shingle or a 2 gram, okay, K equals 2, that means that the sliding window is 2. So you basically look as if you're looking through a viewport over the first 2 characters, list that as one of the elements in the set, slide it over 1 character, and now you're looking through your viewport at the next 2 characters, okay, which includes the last of the previous. So you've got BC, okay, and then CA, and since we're dealing with regular old sets and not multi-sets, I get an AB again, but I don't list it again. Okay, so don't list it again, but that is an option, but that's not how you're going to do it on the test. Capiche? Copacetic? Yes. For the test, you do not use the multi-set version, you use a regular set, which means no duplicates, right? No duplicates. Okay. So you don't have to worry about the hashing or any of that fun stuff, but you do have to worry about how to do Jacquard similarity, and that's on slide 9. So basically slides 9 and about 15. So 9 through 15, 16-ish. Not worrying about the hashing. You'll have pretty much all you need for the Jacquard similarity and stuff. Okay. Take your time on this because it's kind of high stakes point values on single questions sometimes. I think this one is multi-part also, if I remember correctly. But you know, it's still like you might be like just knocking 5 points off here, you know, left and right just because you didn't read the question right or weren't paying attention. So don't do that. Okay. Are we good? Vast majority of people, again, they did pretty well on test 2. I would say more people were on the struggle bus for test 1 than test 2. Test 2 has so far had a higher success rate and higher percentages overall. And the majority of the final is based on test 2 material. So you may, was that next door? It must have been next door. I just heard, that's not me, is it? Got really loud. Okay. What's that? I think someone probably turned on their speaker or something temporarily, and their microphone picked it up, and then it could have turned into a recursive disaster. It would have been sad. You ever gone to the bathrooms in the castle building? You look at the mirrors and think recursion? Like, no? Like, it looks like you're looking down a hallway of mirrors because there's a mirror behind you and a mirror in front of you. Right. Yeah. The base case is it gets down to photonic level and then it's done. So I guess there is technically a base case. So can't see it though. I totally can't see it. Eyes are bad. Any questions about the Jacquard similarity fun stuff? All right. Any Jacquard similarity questions? No? Okay. Any questions about any of these topics? Okay, so we got, I would say if you did not do well on the first test, then I would say put most of your effort toward the, making sure you're confident with the second half, but then going back and maybe spending the majority of your time on the first test stuff. Okay. I know I haven't graded all the tests, but I've graded, of all the ones that have been turned in up to about yesterday at like 4 p.m. or something, I had graded. I don't remember, but I graded the majority of them. So there's probably more I'm going to be grading this evening, and definitely over the weekend, and also grading finals as they come in. But those usually don't start. I get 1 or 2 during the first few days. So, and then on the 13th, everyone's like, oh, they start screaming and wanting extensions. It's like, oh, I'm sorry, I didn't give you 2 weeks to do this. So if you get sick or something, I mean, it makes sense. It's like, okay, that's sad, it's upsetting, whatever. But if you're just like, I'm sorry, I forgot I was taking a class. That's no, I did get that excuse once. I'm sorry, I forgot I was taking a class. Yes. You can submit, well, there's the rub. If you could submit it a second time before I get to it, yes. Yeah. Yeah, you can, if you notice something like if it's something relatively simple, yes, not after I've graded it. That's the problem. Okay, so I do try to grade them. I usually try to give you at least a little bit of time after the submission, but try to make sure you can consider that once you've submitted it, it could be anywhere from 15 minutes up to about 4 days until I'll grade it. So just assume it's in that time frame. That's why I'm saying please, once you've actually done it, like read over it very carefully. Okay, so I'm not saying you can't turn it back in. If something happens where you're like, look, I know you graded it, but seriously, I did have it and if I kind of trust what you're saying and it's not, look how I scribbled out my answer and put yours, then I will probably be a little more kind, but I just don't want like 50 students emailing me and saying, I resubmitted it after you graded it. Yes, I've had a couple students on, not necessarily this class, but I've had a couple students say like, I saw my grade for the test, can I redo it? Like, I'm like, that's bold. It's like, I didn't like my grade for the test, can I just redo it? I'm like, I was like, that sounds fair to everyone. Okay, that's a participation trophy right there. That's not bueno. But yeah, no, I mean, stuff does happen though. Like if you get sick or something, like if it was something kind of silly, like there have been a couple where the PDF format was like weird and I didn't see it right, or it missed a page and it was supposed to do it. There was Canvas issues. I understand that. Like that's fine. If I'm like, hey, email it to me, I'll fix it. That's fine. But if it's like I just didn't like my grade because I had the wrong answers, that's the not into that. So any questions about this stuff? Any questions? Any questions from our online audience? Anyone? Oh, there's a thumbs up. Is that a question or just a thumbs up?
It's just a thumbs up.
There we go. Okay, we've got a chat. All good. Okay, good. 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 More thumbs up. Good. We're getting Luca. Luca has decided that it's a thumbs up also. I'm glad everyone's excited. Everyone excited for the test? Well, I mean, you don't really get excited for tests, but anyone get excited to get it over with and like sail out into the universe and give me fantastic ratings on both Rate My Professor and the official document through the school. Yeah, do try to get to that though. If you do get a chance, please try it, because it was like 20% response rate the last I checked, and that's a little low. We like to see he's ecstatic. That's good. Yes, he's ecstatic to do it. All right. Everyone else have other finals this week or other final projects starting and other fun stuff? Yeah, it's good. It's a good time. It's a fun time. It's a cold time. Very cold time. All right. You're dismissed. I will end the recording. If anyone has any additional questions, you are welcome to come up and ask. Or I will stay on, even though I'll end the recording and stop the share, I will stay on Zoom for a little bit longer. If anyone else pops in. Okay, stopping share.